Is time travel possible? The human mind is fascinated by the idea of venturing through time. Could we one day journey to the past or witness the future firsthand? While the concept may seem like science fiction, it has captivated scientists and dreamers alike for centuries. The possibility of time travel is a captivating thought experiment, a journey into the very fabric of our universe. Imagine standing at the edge of a time machine, ready to embark on an adventure through history or into the unknown realms of the future. The allure of witnessing pivotal historical events or catching a glimpse of technological advancements yet to come is undeniably tempting. But is such a feat truly within the realm of possibility, or is it destined to remain confined to the pages of science fiction novels? In the early 20th century, Albert Einstein, a renowned physicist, proposed a groundbreaking theory that would forever change our understanding of space and time: the theory of special relativity. This theory, a cornerstone of modern physics, fundamentally altered our perception of the universe and introduced the concept of time as a relative entity, rather than an absolute one. Einstein's theory shattered the long-held belief in a universal clock ticking at the same rate for everyone, regardless of their motion or location. Einstein's theory of special relativity postulates that time is not constant, but rather is intertwined with space, forming a four-dimensional fabric known as space-time. This mind-bending concept implies that time is not a rigid, unchanging entity, but rather a flexible and relative one, subject to the influence of gravity and motion. According to Einstein, time can be stretched and compressed, much like the fabric of a trampoline, depending on the speed and gravitational pull of nearby objects. One of the most intriguing predictions of Einstein's theory of special relativity is the concept of time dilation. Time dilation refers to the phenomenon where time passes at different rates for observers who are in relative motion to one another. In simpler terms, time slows down for objects that are moving at speeds approaching the speed of light relative to a stationary observer. This means that time is not absolute but is relative to the observer's frame of reference. The concept of time dilation has been experimentally verified through numerous experiments, providing compelling evidence for the validity of Einstein's theory. One of the most famous experiments that confirmed time dilation was the Hafele-Keating experiment conducted in 1971. In this experiment, 4 highly precise atomic clocks were flown around the world on commercial airliners, while an identical set of clocks remained stationary on the ground. Upon comparing the clocks after the flights, the researchers discovered that the clocks that had been flown around the world showed a slight time difference compared to the stationary clocks. The implications of time dilation extend beyond the realm of theoretical physics and have real-world consequences. For instance, astronauts aboard the International Space Station, which orbits Earth at a high velocity, experience time at a slightly slower rate than people on the ground. This difference in time, while minuscule, is measurable and has been confirmed through experiments. Astronaut Scott Kelly, who spent a year aboard the ISS, returned to Earth slightly younger than his twin brother Mark, who had remained on Earth. This difference in age, though incredibly small, is a testament to the reality of time dilation. In essence, Scott Kelly had traveled a fraction of a second into the future compared to his Earthbound twin. In a sense, we are all time travelers moving through time at the steady rate of 1 second per second. However, the possibility of manipulating time, of accelerating or reversing its flow, remains a tantalizing enigma. While the technology to build a time machine like the ones depicted in science fiction may be far beyond our current capabilities, the study of time travel continues to captivate our imaginations and push the boundaries of our scientific understanding.